All right, so we have the last homework assignment out. Just literally, you watched me post it right now. So let's take a look at what the last part of this course is going to be. Homework 10, streaming. So for this homework, we want to stream video to a user. If a user wants to watch some content, we want to stream that to them, have on-demand video, but also the large goal of this week is to let them watch video without having to download the entire video file. We want them to be able to download the video in pieces and stream those pieces to them. So let's just go through these objectives. Objective 1, MP4 uploads. This is the same objective as image uploads. This is here to kind of reflect if you did not get the full image upload objective that you will have to do that work to complete this assignment. So this is to reflect that if you didn't do that before, I want to give you some points for that effort that you have to put in this homework. If you're doing all of the buffer and the multi-part form parsing just to get to 0 points on this assignment, I feel like that wouldn't be super fair. I mean, arguably it's fair, but I put objective 1 there. If you have, to give you some points there, if you already have this complete, if during homework 4 for image uploads, if you have your buffering working great, if you do your multi-part form parsing that data and everything's perfect with all that, you already have objective 1 done. So uploading large files, doesn't matter that they're MP4s instead of PNGs and JPEGs. It's the same thing. It's a bunch of binary. It's a bunch of bytes coming over the socket. There's not much to nothing special that those bytes represent a video instead of an image, or a video instead of an HTTP request. It's all the same thing. I guess it is an HTTP request, but like a GET request. So file uploads. Well, we're familiar with that, and we can talk about buffering, especially during Q&A. Those of you who just took a loss on homework 4, we can talk about that again during Q&As. Next one is I'd say probably the biggest part of the assignment is objective 2 is setting up a way to do video processing. Now for this, you can use outside, I don't want to say outside or external. You can use this software, FFmpeg, which is what we're going to use to do any video processing that we need to do. So you don't have to do the manual video processing, which I was considering to be part of the assignment, especially given the way this semester rolled out. I think that'd be way too much. So we're going to use this software to do the video processing for us. Actually, I don't think that fits in this course anyway. To do the video processing for us, and you are allowed to use libraries for the bindings to this software. So FFmpeg is going to be software that lives on your machine. Now you can make, and you can go into the command line and use this software to process your videos, use a whole bunch of command line arguments, and process your videos that way. We need to process videos programmatically, so you can make syscalls and make syscalls to your command line from your code. If that's not something you've done before, just know that you can write code that effectively types in commands in the command line for you. So if you want to connect your code to some other stuff that's on your machine that's not written in that language, one of the simplest ways to do that is to make a syscall and use your command line. If you want to, do something simple like well, you wouldn't do this with syscalls, but for some reason this is the first thing that popped in my head. If you want to scan a directory for all the files, you could make a syscall to the command ls and then read the results, read the standard out of that syscall, and then read the directory structure of your of that directory. With FFmpeg, this is a software that you can use via command line. So we could do the same thing with syscalls. We can call the command line, call this program, and have it do the things we want it to do. But I am going to allow libraries that have bindings for those syscalls, so you're not writing the syscalls and the command line stuff directly. You can use the libraries, which clean up the syntax a bit. Instead of just dumping a whole bunch of command line arguments, it's going to add a little bit of syntax to that to make FFmpeg just a little bit easier to work with within your code. So for this objective, setting all of that up, getting FFmpeg installed. This is a separate program that runs on your machine. Getting it installed, adding it to your path, so you could go into the terminal and type FFmpeg and have it run, have it do your processing that way. Once that's set up, you can get the bindings, or if you prefer to do syscalls directly, that's your option. You can do that, but get the bindings, and then write just anything at this point. For objective 2, just write anything that uses FFmpeg to get some credit for setting up the library, the software, the bindings, messing with your path, going through all that stuff. That's this whole objective. So do anything. If you want to grayscale a video, if you want to flip a video, you want to change the resolution, I don't care what it is, just do anything to a video. Take something that's in one of the tutorials and just do anything with that video. So that's objective 2. So a library that does the syscall is allowed for us. Yes. So each language has something built in to make syscalls. You're certainly allowed to use that library. But I'm allowing you to go a step further. You can use an FFmpeg binding library, which will specifically make command line. Let me click on Python today. So if you get so this is a library that's going to bind Python and FFmpeg. I don't know if that's the right terminology there, but it's going to make the syscalls for us. So somewhere in this library, we're going to find let me just see the top level. FFmpeg, import FFmpeg. I guess that was obvious. It's not one of these libraries. Kind of. Oh, this is supposed to be quicker. I thought this was going to be an easy one. I just wanted to show where it's making the command line calls. Really, I thought this would be a softball one. I thought I'd find this in no time. Alright, well, never mind. I'll try setup. I don't think this is where it's going to be, though. I really thought that was going to be an easy one. But anyway, somewhere in that library, it's making a syscall to the command line. So you can make those syscalls directly, but this library is just adding some syntax to make those syscalls more digestible, easier to write, easier to read. The command line arguments, if you mess with the command line, it can the command line can get cluttered, those calls. And with this library specifically, there are like 8 different arguments that we have to maintain. The binding just makes it a little easier. In command line, making complex command line calls just isn't what this course is about. So let's pull in a library and focus on the networking side of it. So the library that does the syscalls for it. Yeah. Oops, I already read that. Is FFmpeg allowed? If it's a binding for FFmpeg, then yes. You don't have to use specifically the one I just showed. If you want to use one of the other options, in those libraries, as far as I know, every language I check, there's bindings out there. For Python, there's like 10 different choices. If you want to use one of the other ones, go for it. As long as all that library is doing is taking your code and then turning that into a command line call to FFmpeg, then that's fine. So do anything, set all that up, do anything with FFmpeg. That's objective 2. Objective 3, now that you have that set up, convert an MP4 file to an HLS video. This is where we're getting our streaming happening. So users are going to upload MP4 videos. We're going to use FFmpeg to convert those into HLS videos, which is effectively chopping the video into smaller segments, and then host that HLS video to send to the for the users to consume. In today's lecture, we're going to talk about objectives 1 and 4. Actually, no, we're not talking about objective 1. We're only talking about objective 4, I suppose. We're going to start at the end. So today we're going to see if you have an HLS video, how do you host that for the user? And then Wednesday's lecture, we're going to talk about the FFmpeg stuff, doing the conversion from MP4 to HLS. And I guess objective 1 we've already talked about. Again, we can talk about objective 1 in Q&A, but everything for this has already been covered in previous lectures. So with that, it really bugs me, but oh well. So with that, let me try to find my slides. Let me look at FFmpeg. I'm pretty sure that's one of the. Yeah, it exactly says what it is. Just simplifies the syntax of the command line calls to FFmpeg. So notice this is a strong source of it works on my laptop. So just be aware of how this works. I mean, we'll talk about it in more depth on Wednesday, but you have to have FFmpeg installed. Which, of course, when Nick and I test your assignments, we're going to have FFmpeg installed. You have to have it installed, and you also have to have that added to your path. So if you go to your command line and type FFmpeg, you should have access to that software right there with exactly that being typed. Then the library is going to look for that executable on your path, and if it finds it, it's going to work. If it doesn't, it's not going to work. So if you move to a machine where FFmpeg is not installed, things break. So just be aware of that. That shouldn't be an issue. But just so you're aware. Because the same exact code running on 2 different machines can have different effects. All right, so let's talk about a little bit of background here. And talk about streaming. So what we want to do is build a video sharing site very similar to the image site for Homework 4. For Homework 4, just quick recap, users could upload images, and you would host those images, and you had one page where users could view all the images that have been uploaded. So that's what we had for Homework 4. We want to do the same thing with Homework 10, with, I guess, one exception. Technically, the way I wrote up the homework, it doesn't have to support multiple videos. So if you don't want to worry about the HTML templates and viewing all videos on a single page, it's technically you're off the hook for that because I forgot to add it to the doc. And I already released the doc, so I'm not going back on that. But you do have to support video uploads, converting that to HLS, and then hosting that for the users. So the problem with this that we didn't have in Homework 4, the big addition to this, is that videos can be huge. These can be extremely large files. And in the doc, I'm sure you saw it, I didn't mention it, but you should support videos of at least 100 megabytes. That's a pretty arbitrary number, but I just want to make sure, like some of you for Homework 4, I said pretty large files, or I forget how I worded it, but I had many of you, presumably, I would probably guess not the ones who are listening to lecture live, But some students in the class just increased their buffer size to like 10 megabytes and called it good. And they completely bypassed all of the buffering. So 100 megabytes, I think that's large enough that, I don't know, maybe they can technically do that, but I want to avoid that. So 100 megabytes, pretty arbitrary, but the problem is with working with videos, these files get large, and we want to be able to work with these large files. Just increasing our buffer size to larger than we think anybody will upload is a ridiculous approach, and we just can't do that. We can't do that at this level. So these videos are large. The bigger problem is, so with uploads, if our buffer is huge, it's terrible, but it's not the worst thing in terms of user experience. What really gets bad is when a user watches a video, we don't want them to have to download the entire video if they're only going to watch a portion of it. And we also don't want to take up all that network traffic if they're only going to watch a portion of it. So our whole goal, most of our goal this week, is to send that video in small segments, so we're not sending the entire video all in one shot. That's our primary goal, is to chop up this video. So before we get into that, let's talk about how a user is going to consume a video and how we're going to host it. And luckily, since HTML5 came out, this is super easy. To host an MP4 file, we use a video element, and this is very similar to just having an image element and having a source to an image. Here we're going to have a video element, and we're going to add the source to the video, and also the MIME type of the video we have to specify. And then we have some extra options that we can have for this. I'm using the controls option, which gives you the play button, the pause button, and those controls at the bottom of the video player. So with this is going to make a request to your server for space.mp4, which presumably exists there. The user is going to download that entire MP4 file, and then it'll start playing in this player. When you do this, you're going to get the default video player that's packaged with whatever browser your user is visiting on. And that's how they're going to view this video. So let's take a quick look at this. Where is my mouse? Let's take a look at a very simple site that I have set up. It's Flask. And the Flask is doing nothing but hosting my static files. I only need static files for this example. So I have a very, very simple server that's just hosting everything in the public folder. My public folder, a little bit of spoilers here, it's going to have some HTML. And I meant to clean this up a little bit. Not much. So here's mostly the example that we saw in lecture. Might as well get it exactly there. If I load this page, my app should be running already. If I load this page, oh my goodness, where am I? Did I? Yeah, I did. I'm going to get the controls that we were promised, a play button. I'm going to get to see this video, this amazing video in all its glory. And let me change the size too. And I'm specifying only the width, and then it's going to take the aspect ratio of that video and show me that video in the intended ratio. I just want to specify the width so I have a little bit of control. But we can see this is the default video player that we get. And to be honest, I never really paid that much attention. But if we go to I had to re-download VS Code. But if we go to a different browser, we're going to get a different video player. So, oh, come on. We're going to get a different video player. So we're getting whatever the browser has as their default player. That's what's being played. So you can see if I open this in, not Internet Explorer anymore, Edge. If I open this in Edge, I'm actually getting a different player. Since I specified controls, it's still going to show me their default controls for this video player for this browser. But the controls are going to be different. You see I have different options, different styling. I have just differences across each browser because I'm using their default browser. Whatever's built into that specific browser. But it was super easy to host a video, and that's the important part there. To just host a video, very simple. Give it a video tag, use the default browser, done. So the video tag not have any streaming capabilities. It does kind of. It's a surprisingly tough one to for me to answer at the moment. So I thought it didn't have any, and I still don't think it does, just based on my understanding of all this stuff. But when I load this video, it does. Let me set up my whole example, and I'll explain this a little more. But it does download this entire video, but it starts playing the video before it's done downloading, which is just really tripping me up. Why is this taking so long to download too? It's all localhost, so this should download in no time. But it shouldn't be able to play an MP4 before it's finished downloading, which is really tripped me up in testing. If anybody understands that one, I'll have to really do some research on that. Because for my understanding of MP4 is that you have to decode the entire file before you can get any video actually being rendered. Yeah, if our server is waiting, if you're doing something like send all with your server and just sending all the bytes in one, no, that would work too. But yeah, it is doing that, but it shouldn't be able to. That's what's tripping me up. It shouldn't be able to. So I might be misunderstanding how MP4 is encoded. But I always thought you had to get the entire MP4 file before getting anything. So I wonder if this is something that Flask is doing for me, because this shouldn't be possible. But it is doing some form of streaming, which it shouldn't be able to do. So that's something I want to look into deeper. That's something I want to do a deep dive on my own time. Figure out exactly what's going on there, because that video tag had surprisingly good performance. But it does, for our purposes, at the very least, it does download the entire file. You saw it downloading just one big MP4, even if it is playing it before the entire thing is downloaded. So if that user only makes it a quarter of the way through that video, they still had to download the entire video. By the time they get a quarter of the way through it, the whole download is going to be processed. All that bandwidth has been used up. All that network traffic, all that CPU time on our servers, all that CPU time on the user end. There are a lot of wasted resources if that user's only watching a small portion of that video, because that whole thing is downloading, even if it is playing, defying logic and playing before it's supposed to. Or defying my understanding. I just might not understand MP4 as well as I thought I did. So we're going to download the entire video. If that's an hour-long video, maybe you're browsing Netflix. This is a pretty common use case, I believe. You're browsing Netflix. You go through like 5 different hour-and-a-half or 2-hour movies and you watch like the first minute of each movie, just trying to find something to watch. If Netflix is sending you that entire video each time you just check out a small portion of it, they're going to be wasting a lot of bandwidth. They're going to be wasting a lot of your bandwidth. Imagine you're doing this on mobile and you got to pay per gigabyte. Those video files are pretty large files. You're going to be paying for a lot of extra data that you never even consumed. Stuff that was sent just for you to watch 1 minute of a 2-hour movie. That's going to be very wasteful at best, and a poor user experience and poor performance at worst. And Netflix, if they do this for every user, they're going to start using up their bandwidth. That's just very wasteful on their end. They're going to spend a lot more money for bandwidth that didn't deliver anything to the user. So a lot of reasons why not to do this, even if we can watch the video. What I thought would happen is you would have to download the entire MP4 before you can watch the first second of the video. That's what's puzzling me. And I want to make these big dramatic, like, you have to download the whole video. And I can't do those now, and it's frustrating because I wanted to wave my arms around a bunch and say, oh, you have to download this whole dang file. But there still are many benefits to this. So what we're going to use instead of MP4 is HLS, HTTP live streaming. This is one of the major methods of delivering videos in a streaming manner over the internet. There's also MPEG-, which is an older, more tried and true, I should say, video streaming method. HLS is one of the fairly newcomers. I believe it was around 2012, if I'm not mistaken. So fairly new in terms of adaptation. You have to have every browser. Same thing, same story as we had with WebSockets. You have to have every browser adapt a new technology, and your legacy browsers, those old browsers that existed before HLS existed, don't really work. Luckily, we do have some workaround for that with HLS, in that some browsers still don't support it. So we have to have workarounds. So Chrome, most notably, since that's most of the traffic on the internet, doesn't support HLS natively. So since Chrome doesn't even support it, we have to have other solutions to be able to play HLS videos anyway. So we actually end up getting some legacy support out of that because we have to have other solutions. So with HLS, instead of storing one large video file, we're going to chop that up into segments as promised and host those segments. So MP4 compresses by recording difference between each frame. Okay, that makes sense. So as long as you start from the beginning. So the context of my understanding of MP4, I always use this as an example in TCP. How TCP, if you drop a packet, you recover that packet. One of my big examples was if you have a gigabyte large MP4 file, you're downloading a movie, for example, and you are not, if you weren't using TCP and you dropped one single packet, you wouldn't be able to decode that movie. You'd have a corrupt file and not be able to read that movie. So I'll have to update that. You can still watch that movie up until the dropped packet, which makes sense. But once you lose a single frame in the video, the rest of the video after that will be corrupt. That makes sense. And since we're downloading these and we are using TCP, we are downloading it mostly in sequence, or at the very least TCP is resequencing. So we'll have from the beginning up until it's downloaded. I see. Thank you for that, Tomend. That makes sense. That's in line with my understanding of the compression too. So, but if like the first packet were dropped, my example still works with TCP. If the first packet's dropped, your video's complete garbage. You can't do anything with that. So again, so you don't have the starting point to know the differences. Okay, yeah, that makes nothing but a lot of sense. Looks like there's a version 1 and 2 of MP4. From a quick search. Yeah, I'm sure there are other solutions to streaming video. I just chose the most popular one so we can get some experience. I'm not familiar with MP4 V2 specifically, but But I assume it does something similar, in a similar manner. Probably read about it one time and forgot. But at any rate, HLS, we're going to chop this video into multiple files. We're going to have one index file with a .m3u8 extension. And this index file is going to contain a list of all the files for this video. So this is a big... so this is the file that will initially request. This is the entry point to the video. The user is going to request that index file. That gives them a list of all the files that they can request from our server to consume this video. And then we'll have many .ts files which will contain those segments of the video that can be downloaded one at a time. So once we have HLS, once we have an HLS video, we'll host the M3U8 file and all the TS files on our server. We'll host all those as static content, and then the user can request the M3U8, which will tell them which TS files to request to consume this video. In video, you can skip a frame. It might look a bit off, but it'll fix it. But not with the MP4 encoding. If the MP4 file is missing a frame completely, then you're missing some of that information for the encoding. Since the encoding is working off of the previous frame. So you would have some cascading errors if you missed a frame. And I believe, if I'm going way back in my understanding here, but I believe MP4 does have, at fairly regular intervals, some correction, like some complete frames every once in a while. So the artifact shows up for a while until you hit one of those correction frames, which contains all of the information for an entire frame. I believe is how it works. So I don't think you would lose the entire video if you missed a few bytes, but you'd have some corrupt pieces of the file, pieces of the video. HLS, as I mentioned, does not work with those built-in browser players. You cannot depend on those. It doesn't work in notably Firefox and Chrome, Opera. It might work in some other browsers. It might work with Safari and Edge, possibly. But, I mean, we're already missing 99% of the market share. So we need some other solution. We need TLS for HLS to work. No. No, you can send HLS videos unencrypted. In fact, I'll do it for my example. I don't have my encryption key set up. There's I forget what it was. There's a technology in this area that needs to be encrypted. I forget what it is though. I forget off the top of my head. So HLS is not in these built-in browsers. So we're going to have to pull in a library for this. And this is something I realized we didn't actually cover yet, is JavaScript Libraries, which arguably should have went in last week when I was talking about supposed to be talking about more front-end stuff. Should have talked about JavaScript Libraries at that point. But regardless, it says uses, only... So I mean, this is my syntax, how I say either HTTP or HTTPS. So with the square brackets, the S is optional. It can be there, but it might not be. It's just the way I'm using that. So HTTP or HTTPS. But notably, the reason for this bullet point is it's notably not a new protocol on the networking side of things, on the web side of things. Whereas WebSockets, it started with HTTP or HTTPS, and we upgraded to a different protocol and had a whole different form of communication by keeping that TCP connection open. This bullet point is to distinguish it from that. It's not a whole new application layer technology like WebSockets were. This is just hosting files over HTTPS, and then when the client receives those responses and gets these files and gets this content, the client is going to do something different with that content. But to the application side of things, the network side of things, the web side of things, all this is hosting static files, and then in JavaScript processing, playing those files. The web side of things doesn't so much care. about the web technologies, HTTP, TCP, TLS. None of those care that we're using HLS. That's what I mean by that bullet point. By it only uses HTTP. So let's talk about JavaScript libraries a little bit. I have this one will be a fairly simple example, but I realized I never had this content in the course this semester, which I would have had. I would have covered this last week if I remembered that I didn't do this in weeks 1 or 2. So let's just go through a quick example, a simple example of downloading a JavaScript library, which is something probably all of you have done on your projects already. So I'll go through this pretty quick. But if we want to download a library in JavaScript, we put a script tag with a URL in our HTML, usually either in the head or at the end of the body, depending on when we need this library to be loaded. And this script tag is going to tell the browser, hey, go to this URL, download that code, and interpret it as JavaScript code. Once we do that, we're going to have all the functions, all the classes, anything that's in that library is going to be available to us to use in our code. So this is as opposed to server side. If you need libraries, you have to download those dependencies somehow. Have some dependency management for that, pip, npm, maven, something like that, to be able to manage your install and manage your dependencies. In the front end, we can add these script tags. You can get more advanced and have more packaged front ends, but this is the kind of the standard way, the traditional way. I don't have the right word for that one, but this is how we can download these libraries right in our code. So it's going to download the library, which is, for this example, is going to give us the time in a nice format. This is literally just a bunch of code. I wanted the code itself. Oh no. Do I really have my slide set up that you can't? Text selection. Maybe it's just the software I'm using. Yeah, there we go. So if I take this, paste it in my code, but what I want to show is this this URL. This would just be like if I did source my javascript.js, which would make a request to my server and get that JavaScript code. The same thing is happening, except we have a path on the internet. We're going to connect to it with HTTP, but it is literally the same thing as we do when we host JavaScript on our own server. We're just getting some JavaScript. It's running when it's downloaded. It's just code that somebody else wrote. So it's just like any other library for any other language. We're just grabbing somebody else's JavaScript and throwing it into our website. So whenever you have these script tags, that's exactly what you're doing. You're just downloading somebody else's JavaScript. There's no magic to those. Just somebody else has a server on, in this case, momentjs.com. They have a server where they're hosting a static file. You're downloading that file onto your website and then using their JavaScript in your code. Same thing with Bootstrap, jQuery, any other libraries you're using. Is this literally going to their server, making an HTTP request, getting that JavaScript, and running that JavaScript on your web page. So that's what JavaScript libraries are. So we're going to add that to our JavaScript. Yeah, we literally download their code. And once we have this one in particular, I want to get away from my slides at this point. I think that's all that I want to talk about. The rest is what the library does. I'll just go and take this example, put it on the website. this isn't the neatest example, but so I'm going to paste this into my code. This is going to call the library. This is my library that I got from this JavaScript. I'm going to call this library and get the current date in a specific format that I'm specifying. And I want to display that on my website on a div called datetime. So I better have a div named datetime. And now I'm going to call that function. Do I have auto? I don't want this. And I want to call that function every second. So if I reload my page now, I should have a clock. And since it's updating every second, I can watch the current time. Should be exactly the current time. It tells me I got 5 minutes left in the lecture portion. And I can take advantage of that library to be able to get that functionality that I need, is what we're seeing there. Is that I got the JavaScript for this library. This library gets the current time and formats it however I want. And then I can display that on the page easily. Instead of trying to get the current time, computing all of the, like if you try to do this manually, what all this code is doing, get the current time. Actually, JavaScript has a good date time built in, doesn't it? But if you try to get like the current time in milliseconds, the epoch time, and try to compute the exact time in a human readable format, that's actually quite challenging. You got to worry about all the leap years, leap seconds, daylight savings. There's a lot that goes into that computation, time zones. This library is going to handle all that stuff for us. All right, so the reason we want to talk about libraries at all in this context is that video player does not, the default video player, we cannot rely on that playing our HLS videos. So here I have an HLS video. I have my M3U8 file, which is going to give some meta information about the video itself, and then the names of all of the. Oh, that's why I was downloading everything in triplicate. My file here is listing them in triplicate. So it's going to specify all of the TS files, and then I have all the TS files. I have all these hosted. These are just binary video data. All those hosted on my site. And then if I get this library here, I need a video player that's going to play HLS videos. For that, I'm using Video.js, which their website tells me they are the one to use. So, hey, I'll believe them. But Video.js, this is going to be the video player that I'll use. You can use this one. If you have a different one that you'd like to use, go for it. But I'm going to download the JavaScript library. This library also has some CSS to stylize the player itself. And then I'm going to set up the same syntax. The library works with the video tag, the video element. The width, the ID I'm not even using right now. Delete that. I'm going to tell it that this should be a Video.js file, and then the library is going to know what to do with that. Give it a setup JSON object or JavaScript object, I guess, technically. No, it would be JSON. Anyway, give it a setup string. I'm not doing any custom setup for this one. And then any other options that I want. The controls, and then I also added autoplay and muted to this one. And then for the source, I'm going to specify my M3U8 file and change the MIME type to be the proper MIME type for HLS videos. Now when I go to my page and I reload this thing, you should see 2 videos. And I should see my HLS video, and notably, we can see that that index file was downloaded first, and then once the server knew what to download, it is, I don't know why my index file has everything in triplicate, but it's downloading the same file 3 times for some reason. You know, those are different. Is there a character difference that I'm not seeing? I don't know. But it is downloading all these TS files, and notably we can look at our timing on this is the full video. See, why did that not take forever this time? Before it was taking a long time to download this video. But half a second to download this video, the full video, and then each one of these is taking 3 milliseconds to download the whole thing. And stalling, you know, it might have been stalled because we were waiting on the MP4 to download. But we get that video in chunks, and we have streaming video. If I only watch a little bit of this video, I'm only downloading a little bit. I'm only downloading a portion of that video. So we get the proper behavior that we want. So streaming is not a persistent connection. The browser just knows which fragments. So streaming can be, depending on, so the word streaming is kind of overloaded. You can have a streaming connection, but with consuming video, that's just not typically how it works on the internet. But you could have a stream, like the word streaming can mean you have a stream of bytes just continuously coming in. For HLS, for HTTP live streaming, that's not how the technology works. We kind of simulate that streaming effect by chopping the file into these smaller portions. You could have a data stream, kind of like WebSockets. We have a persistent connection. We can stream data over that connection, but we're not. We don't have a consistent stream of bytes. If you have a consistent stream of bytes, like there has to be some start and end point to each chunk of information. It's unlikely that you're going to have a situation where every single byte matters. Like if I get one more byte for the video, I can't process that byte until I have more information. So I have a good chunk of the video, at the very least 1 frame. So streaming the bytes directly isn't really practical. And does the screen size matter? I'll say no. I guess it depends what you mean by the screen size mattering. Actually, let me comment this out and see the faster loads. So I'm specifying the width here in pixels, and then the height is going to be scaled based on the aspect ratio of the video. So the screen size, like my actual size of the screen here, isn't going to matter. The video is just going to take up however many pixels I specified. So if I resize this isn't, I mean, we could set it up. We could use some more libraries and set this up, or get into our CSS. to customize this and have it scale as I adjust the size of the browser. But that's not how we have it set up right now. We could do that if that's what you mean, to be responsive to the size of the window. But right now in this example, the screen size is ignored by the content. And notably, I feel like I'm using that word a lot. The browser, the video player itself is different. We have different controls here. And if we take this, I closed Edge. Edge, I'm going to give you one last chance to ruin lecture. Oh, it is. Okay. You scared me there, Edge. That one makes sense, though. We have the same browser in Edge. Any browser we go to, since we're using our own browser, well, not our own browser, but since we're coding our own browser saying use this browser from this library, I'm getting the same style, the controls, the same player, same everything for this player. So another advantage, if you like consistency across your cross browsers, especially, instead of using that default browser that each browser's that default video player that each browser is going to have implemented differently, we're going to use one browser with one consistent scheme of controls. And this library in particular has a good way of customizing the look and feel of the browser, or of the video player. So if you want to customize this, if you don't like the default controls, you can add in, you can customize that to have your own styling to it. And then that styling is consistent across browsers. So aside from being able to play HLS, we get some other advantages by using a consistent library across our pages. And one last thing, I do want to show this just because it frustrated me so much. I'll at least share my frustration, I guess. If I uncomment this, this will be the last thing I show. Change this to autoplay muted. Make these smaller again. And refresh. What I would have liked to happen, because it would have made a great example in lecture, is the HLS video. I expected that to load much earlier than the MP4 video. And it's just not the way it happened for my example, unfortunately. So even though, yeah, there we go, that space video, the MP4, it's still downloading, but we're able to play the video beforehand, which makes sense after Taman's comment. That makes a whole lot of sense why it is able to do that. But it took away one of my big talking points of look at how great HLS is. 42 seconds is still not downloaded. Where our TS files, they're still downloading as well, but if I pause this video, I pause those downloads as well. These stop downloading, but this still taking up bandwidth. Oh, I mean, I didn't pause that video, but it's still going to take up bandwidth, still getting that. Don't pause on me. It doesn't. Well, I guess it does that too. Well, MP4 is just cooler than I thought, apparently. But, the MP4 is taking away so many of my talking points here. But we do still see advantages to HLS. Just not as many as I was hoping for. I was hoping to sell it as this really badass cool thing. I'm guessing we still have to use HLS for... Yeah, you have to use HLS for the homework. Or, yeah, HLS for the homework. Yes, I mean, there still are advantages. So, one that we'll see, and that you see all the way, everywhere on the internet, is variable bitrate. So, with an MP4 file, you get one shot to guess the quality that the user can consume. If you send a 4K video to a user and their internet connection just can't handle that, they're going to have a lot of buffering. They're not going to be able to watch that video very well. With HLS, we can have the index file and TS files for various different resolutions, and then that's when you get, your network has a hiccup and you're watching a video, it just converts down to it just switches to a lower resolution. That's a feature that we get with HLS. So that is still a selling point that I'll be able to get out there. I didn't add that as a requirement to your homework. Maybe next year it'll be a requirement for the homework. But we will talk about that in lecture. So that I still get that selling point, I still get that talking point, and say, look, when your internet connection is slower, it just automatically switches to 240p. We'll still get that. But a few of my talking points crumbled with the MP4, having apparently more features interacting with the browser than I expected. I'm surprised that download paused, though. That one really trips me up. This download shouldn't be able to pause. Because how does the server know that I just hit pause? The server has to still be sending this information. My guess is that the browser just isn't reading that information from that connection. So if I unpause this, will it have a big jump in the size? No, it just... Okay, so maybe I do still get this talking point. It just requested the file again. And it started that connection over. So the server has to still be sending that, because the server has no idea that I hit pause. But it's actually requesting the whole file. That's actually... Maybe that's even worse than anything else that could happen. Every time I pause the video, the server has to send the entire file again. The way this is happening. Just so the browser can get a little more efficiency. Is that really what I'm seeing here? Because that's what it's looking like. If I pause this and play it, I might not have paused long enough. I pause long enough for it to time out. I might not have waited long enough again. But yeah, that's... The browser... No, I think it is... I think these are all browser features. I mean, my server, unless it's built into Flask, which I don't think, these are all browser features. Is HTTP 1.0 preferred? Oh, why am I using... No, 1.1 is what we've been using throughout the class, what I've been using for examples. Why is this... I don't even know why that's 1.1. But you saw my server. I didn't put much thought into the server itself. It's just vanilla Flask. So apparently Flask is defaulting to 1.0 for this. All right, but let's cut lecture and move to some Q&A.